Now we are on to week 4 and we are talking about scene assembly. The first thing that I want to talk about is the instance node. Now, if you're familiar with instancing and the instance node, then feel free to skip this lesson. So instancing is a vital part of building these huge scenes, and without it, if we wanted to create, say, a forest, then each tree would need to be loaded into memory, and you can imagine how impossible this would be, even with our efficient trees, on, say, a 600,000 tree forest. This is heavy not just on memory, but on build time. So instancing means that we only need the translation information of each point. We still need to load this information, but we only need to load the actual geometry once, which significantly reduces both the memory consumption and the build time. Now, if you want some further reading on this, I have yet to find a better resource than what's already outlined on the Side Effects website. Now, this is in relation to packed primitives, but the theory is still the same, so I would definitely take a look at this on the Houdini documentation website. Now, we don't necessarily need to use packed primitives within Arnold, but we will discuss them a little later. But first, let's take a look at the instance node. So I'll just go to a new scene here and drop down the instance node. So looking at the instance node, we have a few options and a few things that we need to do to get it to work. So the first thing we need to do is activate this, and on the point instancing, changing this from off to fast point instancing. At the moment, Arnold does not support full point instancing, unfortunately. The second thing to notice is the instance object parameter that we have here. Now, if we only had one object that we wanted to instance, we could just plug it in to this space here. But since we want to cycle through a few objects, we will do it a little bit differently. If we jump inside, the first thing that we see is this add node, which really just creates a point at the origin. So we can delete this, we don't need this. The way the instance node works is any point within the node is replaced by the object that you have specified. So let me just drop down a grid. And zoom out a little. I'll also go back to the top level. Now you'll notice that the grid disappears, and that's because this node only wants to show the instances applied to each point. So create a box and a sphere and a tube. I'll also jump inside and alter some of these. Make sure these are polygon meshes for now. And change the radius a little here. And change the radius a little here. Nice. So as we want to cycle through these as our instances, I'll just call this instance underscore 1. It would help if I spelt this properly. Instance 2 and instance 3. And just to quickly check that this is working, I'll just hide these guys and drop this into the path here. Nice, lots of little cubes in a row. I'll just delete this for now. And I want to pin this window just to make sure that we are seeing the final result in this viewport whilst we are inside the node. So I'll jump back inside. So the instance node is looking for the attribute instance, and this is on each point, and we can change this to whatever we want inside the instance node. Now Houdini being Houdini, we have a good few ways to do this, but the easiest way is definitely the attribute wrangle. Now don't worry if you're not comfortable with coding in general. There is very little to almost no code here. It's super simple. Before I do this though, I want to drop down a sort node just to randomize the point numbers. And if I take a look at this guy here, if you can't see it in the viewport, it's fine. You can just unpin it just to take a look at this here for now. And I look at the geometry spreadsheet. Using the sort node, we can change this from no change to random, and then we just randomize this point order. And I'll explain why that is significant in just 1 second. Okay, so drop down a wrangle. Oh, wrangle. And in here, I want to type in S for string at instance equals the path to the object minus the number plus I2A ptnum modulo 3. So what we are doing here is we are creating a new instance attribute called instance underscore, and then adding a number specific to each point that cycles through 0 and 2. The I2A converts this number to a string, or else we would get an error, and the percentage sign here, or modulo, is what is telling it to cycle through these numbers. So if I go to the geometry spreadsheet, we now have this instance which is on each individual point, which goes between 0, 1 and 2. So now if we go back to the viewport, we have this object here cycling through. Oh, sorry, I need to change these to 0, 1 and 2. Okay, so we can see that it's cycling through the geometry now. And the reason for the sort was that otherwise, since this is going in order, 0, 1, 2, 3, 4, etc., etc., we would just have saw square, sphere, cone, square, sphere, cone, in order all the way up. So I just wanted to randomize this first. Now, when we are scattering points on the surface, we won't need to do this, as it already comes out in a randomized way. Now we have randomized objects on each point. We also want to randomize the scale and the rotation. And we can also do this within the wrangle. Now we could create another one, but for the moment we will just do it within the same one. So the two attributes that we want to affect are the p-scale and the orient. And we want to randomize these two. So I'll type in at p-scale equals fit 0, 1, bracket rand, bracket at ptnum, close bracket, comma 0, comma 1, close bracket, and semicolon. Oh. Awesome. So if I now go back to the viewport, you can see we have randomized the scale here. Let me just pin this so we can jump back inside. We can change this to whatever we want, and that will obviously make the objects bigger at the maximum level. And we can control it in other ways. But for now, let's just take a look at the orient version of this. So let's just duplicate this guy and paste it below and change this P scale to orient.y. And we'll change the 0 to a -1. And that's just because the orient attribute is a Houdini attribute which isn't set to degrees. So from -1 to 1 is -180 degrees to +180 degrees. Now we're actually getting randomization on all of these objects, it's just these are spheres and cones, so we can't see it. Nice. Now obviously this isn't particularly user friendly, so we could use the attribute wrangle to create some sliders for people to use if you are passing this on to someone else, or if you just want to make this tool a little more user friendly. So we can create a new parameter. We will say something like f for float at max scale equals channel, which creates a new channel or references an already existing channel at max scale, and close this. Now if we hit this button here, it will create a little slider for us at the bottom called max scale. Now if we want this to read from that setting, we would just replace this number here with the parameter we just created, so max scale. Awesome, so at the moment it's set to 0. If we put it back to 1, we get the previous setting, or we can change it here. So let's do the same for the max and min orientation. Cool, so if we set the max to 1 and the min to -1, we get the same result as we had before. Now these settings aren't quite right just yet, so we can change these using the edit parameter interface. So if we go up to the cog, edit parameter interface, we can see the parameters we just created and we can rename them here. We can also change the range at which they work within. So the min rotate can go to -1. And max to 0. And we can also change the defaults. So in the channels tab here, the default min might be -1. Default max as 1. Be sure to press enter to make sure this works. And apply and accept. Cool. So now the defaults are all set appropriately and we can change these to anything we want. Okay, so now if for any reason you would like to change the seed value here, you can add any number you like to the at point number section. And this just randomizes the values. We could again make this a parameter if we wish. Just create a new line, perhaps make it an integer, I at seed, and then plug that in here after the at ptnum, and we can create the seed value at the bottom. Okay, so Next we'll take a look at the scatter nodes and creating some density maps.